Here, we now talk about partial derivatives, but first, recall the definition of a derivative. Here, we use the notation ddx, acting on a function f of x, and this gave us the derivative of it, at least the first one, and this is given by the definition of limit as h goes to 0, f of x plus h minus f of x divided by h. Here, this allowed us to introduce four really important rules. First, we have the power rule, where if we are given any polynomial to the n power, the derivative is nx to the n minus 1. Here, if we have two functions that are dependent on x, then their derivative follows the product rule, f prime g minus plus g prime f. If we have two functions that divide each other, f divided by g, by the quotient rule, we have f prime g minus g prime f divided by g squared. If we have a function nested inside another function that's dependent on x, then by the chain rule, we have f prime of g of x, g prime of x. And these rules were important for introducing a lot of important concepts in derivatives. Now, we will extend this to multivariable. First, given a function f of x, we intend to ask ourselves, what's the partial derivative of x, and what's the partial derivative of y? The difference here is that because we have two independent variables, we have to take an individual derivative with respect to that variable, otherwise known as a partial derivative. So first, let us discuss about the partial derivative of x acting upon f of xy. This is equal to the limit as h goes to 0 of f of x plus h y minus f of xy divided by h. Notice over here that it's very, very similar to what we have seen with the limit of a derivative. Only in this situation, we have two variables. What we should see is that only variables which depend on x, or which have x, we take the derivative of. So sometimes we like to denote it with this, f of x and then xy, to denote the first partial derivative of x, of f of xy with respect to x. Similarly, the partial derivative of y acting on f of xy is the limit as h goes to 0 of f of x y plus h minus f of xy divided all over h. And similar to the case above, we can denote it as f of y, f of xy, and the partial derivative of f of xy with respect to y. Here, in the next couple of videos, we'll discuss about the partial derivative rules and how they match exactly similar to the rules that we all know in single variable calculus, with the exception of the chain rule. All right, thank you.